Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh and very good day. Now we want to discuss about the solar radiation. Solar radiation. The first I read this slide. Yeah. Solar radiation may be discussed in terms of irradiation, and peak sun hours. Yeah. The second solar irradiance, in here we give symbol G, is defined as intensity of solar power at a point of observation. Okay, the unit in watt over meter power 2. And then solar irradiance. Yeah, solar irradiation. Yeah, we give symbol here H is defined as intensity of solar energy at a point of observation unit in watt hours per meter power 2. Yeah, this one, all measurement and design calculation related to the solar based on energy technology use the integration of power intensities over time to get solar energy intensity. Okay, and then the energy intensity or irradiation may be reported as daily, monthly, or annually values. Okay, okay, look at. Okay, now so we discuss of the solar radiation. Please imagine this one is sun and this one is the space of the earth. Yeah. Now the suns and earth, yeah, we can divide to five lah. The first from here to here, terrestrial area meaning there is no air, and below, yeah, atmosphere. We know atmosphere meaning area that has air. Sun spread heat. Yeah, how many joule? Yeah, yeah, can be mentioned lah in the paper and the others. But in here that I have explained before, the space of this sun, yeah, divided by two parts, inner and outer layer. Sun spread heat, yeah, meaning inner layer, yeah, is hotter than outer layer. The outer layer spread heat, meaning the radiation of heat goes the area of terrestrial and the area atmosphere until arrive the space of the earth, meaning one object in the space of the earth obtain the solar radiation. When the solar radiation arriving, yeah, meaning arrives, goes from the sun, yeah, terrestrial and atmosphere until arrive one object on the space of the earth, yeah, yeah, can occur some happen lah, meaning maybe there is include there is booty water and so on, and maybe if one object here, yeah, one object here in the space of the earth, yeah, yeah, and we want to capture the solar irradiance not directly but maybe reflect. Now, so the solar radiance until capture one, the object in the space can be divided by three parts. After this, we want to discuss. We have the slide of this part. Okay, and then the solar radiation when arrive the space of the object on the space of the earth, yeah, the content of the solar radiation can be divided by two parts. The first, what we can call solar irradiance. Yeah, solar irradiance. The solar irradiance, yeah, is the power of solar. Yeah, or solar or power intensity. Yeah, power. We know that unit of the power is watt. Now, so if we obtain the solar irradiance, yeah, now so the unit in watt per meter power 2, meaning per 1 meter power 2. And then the second is solar, what we can call solar irradiation. Yeah, this one is energy of the solar. And then we know that the unit of the energy is joule or watt hours. Yeah. Now, so the unit of the solar irradiation or solar intensity, so the unit is watt hour per meter power 2. When we want to analyze the solar irradiation, yeah, we can analyze daily, weekly, monthly, or annually. Yeah, depend the available of the solar irradiation data. Okay, now, yeah, please give the focus. Yeah, one focus for this one. When we want to develop one photovoltaic power generation in one area, yeah, the data of solar radiation is very important. Important meaning to decide this area suitable or not to develop one photovoltaic power generation. Okay. How? Meaning how to analyze the available of the solar radiation in one area so we can decide, oh, this area is suitable, oh, this area is not suitable to construct one PV power generation. Now, how to analyze it? The first we have to know, yeah, the requirement or the value of solar radiation, that fulfill to construct PV power generation. Now remember, at least 300 watt per meter power 2, yeah, is available in the area, or 3 kilowatt, 3 kilowatt hours per meter power 2. Yeah, or if we discuss about the peak sun hours, peak sun hours, at least 3 hours. 3 hours data. 3 hours data of solar radiation. 300 watt per meter power 2 is available in the area at least. Okay. How to obtain? How to obtain it? The 300 watt per meter power 2 or above. Measure. How to measure it? If we have to a lot of money, please install. One weather station. Please use. If you want to use the Weather Pro, Weather Station Pro 2, or for the simple or cheap equipment for measure the solar radiation, please use the solar power meter. This it is the simple solar power meter to measure, and then this solar power meter can record the data of solar irradiance. And then if we install the weather station, okay, we have to install it 10 meters above ground level. 3 meters above ground meter. It is at least. Okay. If we have no weather station, if we have no the power solar meter, please estimate. Because at least if we have to obtain the data temperature, we can predict the prediction. the estimation of solar radiation can be conducted. How to it? Please use one of the method to predict, to estimate the solar radiation. Yeah, for example, using the Hargrave method, using the linear regression, or combination of them. Of them here meaning combination of Hargrave and linear regression. After that, we have the data of the solar radiation. Yeah, meaning if we have the weather station, the weather station can measure, if we setting the measurement for the 10 minutes, for example, every 10 minutes, the weather station can record the solar radiation. And then we can obtain 1 day. Yeah, we can take the average. Okay, 1 day, 1 day, 1 day. For example, we can obtain per month. Ya, per month, please obtain the average. Ya, until 1 year lah. Now, so in here we have the data of solar radiation for annual. Okay, now so we have to obtain the data solar radiation. Okay, from this one we can decide how many, yeah, how many watt per meter power to, yeah, that available in the area. Yeah, for example, oh, after getting the data of solar radiation, yeah, the average the solar radiation for the annual, yeah, is 600 watt per meter power to. Meaning this 600 watt per meter power to is required, yeah, is fulfilled to develop photovoltaic power generation. Why? Because it is above 300 watt per meter power to. And then after that we can decide, oh, this area is suitable to construct the PV power generation. Okay, and then for example in the one area after obtaining the data, and then the data of solar radiation for annual, for example, is only 200 watt per meter power to, and then we can decide this area is not suitable. Why? Because it is below the value of requirement for photovoltaic power generation. Why? Because the requirement of the value for the solar radiation is should be above 300 watt per meter power to. Okay, this one, yeah, understand? Okay, next. Okay, and then in terms of irradiance, solar radiation reaching of the surface can divided into following component. Yeah, G global equal G direct plus G diffuse. And then solar radiation that reach the top of it at small as at atmospheric, yeah, is 1367 watt per meter power to, which is called the solar constant. This radiation is largely reflected back into outer space, which is called albedo. When it enters the atmosphere, the solar radiation will be combination of direct beam radiation, diffuse reflective radiation. Yeah, this one. Okay, meaning it is sun. I repeat again. It is sun, and this one is the space of the earth. Yeah, radiation goes, yeah, or spread, and then goes to the terrestrial atmosphere until arriving the surface of the earth. If this radiation goes from the sun until arriving the surface of the earth, there is no happen lah, no something yang menghalang dia punya spread tadi. Nah, so this solar radiation we can call the direct solar radiation. Yeah, direct solar radiation. Maybe there is cloud, yeah, there is water, yeah, kena dia punya water and then goes to the surface of the earth. Yeah, this one is we can call diffuse. or it is from the sun goes to the space one area, maybe there is grass tree and then reflected to the one object in the space of the earth. Now we can call the type of the solar radiation is reflective solar radiation. If one object in the space of the earth obtain the diffuse solar radiation, obtain the the direct or beam solar radiation and the reflective solar radiation, the total solar radiation we can call the global solar radiation. Yeah, this one, yeah. Okay, we can see here, yeah, before. This one, it is sun, and this cloud in the surface of the earth. Yeah, now so normally the highest solar radiation is 1,367 watt per meter power 2. Now this value, around this value, we have measured it. Yeah, we have recorded. Yeah, using the weather station. Yeah, and then maybe cloud here. Yeah, from the sun goes to the cloud, and then goes to the space of the area of the earth. Yeah, maybe it is grass tree reflected, and then wrapping the object of the space of the earth. Now the total we can call the global solar radiation. Okay, look at this picture. Yeah, look at the figure. If it is photovoltaic, same, yeah. If it is photovoltaic, yeah. If it is photovoltaic, sun from here, for example, yeah, because this photovoltaic can operate if the photovoltaic obtain the solar irradiance, yeah, or and temperature, meaning this photovoltaic operate depend on the solar irradiance and temperature. Solar radiation come from the sun, yeah, directly, yeah, wrapping to the photovoltaic. Now this one we can call the beam, yeah, and here, yeah, we have cloud and then reflect here. This one can be called the diffuse. Okay, and then if it is the surface of the earth, maybe this one is grass tree. Sun spread the radiation, not goes to the photovoltaic, but goes to the grass, and then reflective to the photovoltaic. Now we can call the reflective solar radiation. This photovoltaic obtain the beam solar radiation, obtain the diffuse solar radiation, obtain the reflective solar radiation. Now, so the photovoltaic obtain the global solar radiation. Global solar radiation is equal to the beam solar radiation, diffuse solar radiation plus reflective solar radiation. Yeah, when the solar radiation wrapping past the grass tree, the grass tree has the reflective factor. Yeah, this one. We have some formula, yeah, to calculate it, the total solar radiation or the global solar radiation. This one. Yeah, for the beam solar radiation, yeah, IB is equal to A multiply E power minus Km. K in here is optical depth. Yeah, E is exponential, M is ms factor, is equal to 1 over sinus beta n. Yeah, beta n in here is altitude angle. Yeah, this altitude angle is angle forms, yeah, between if we drawn one line from the center of the sun and goes to the one object, yeah, imagine here, and then it is surface of the earth. Now, so this one we can call the altitude angle. And then IDT, diffuse solar radiation, is equal to CIB multiply 1 plus cosinus, yeah, sigma over 2. Yeah, sigma in here is still angle. Yeah, before we give symbol the delta. Yeah, see in here given by 0.091 plus 0.04 sinus, yeah, 360 over 365 multiply n minus 100, and here is number of day, or the other name we can call is Julian day. Yeah, and then reflective solar radiation rho IB multiply sinus beta plus C multiply 1 minus cosinus beta, yeah, over 2. Yeah, this one is till angle. In here is, sorry, this one is beta n. Yeah, please check here. Okay. Now, so the total global solar radiation we can write in here ITT is equal to IBT plus IDT plus IRRT here. Yeah, now so here. Okay, now so for example, yeah, find the direct beam solar radiation normal to the sun's rays at solar node on a clear day with latitude angle of 33.7 degree on May 21st. Yeah, in here we want to calculate the beam solar radiation. Remember, yeah, we have mentioned that the solar radiation or solar irradiance. Okay, if I mention the solar radiation, it is the global name. Can solar irradiance or can solar irradiation? Solar irradiance is specific name lah of the solar radiation. Specific, I mean in term of the unit. Yeah, normally if it is related to the photovoltaic normally take the solar irradiation. Yeah, sorry, solar irradiance. Yeah, for the unit watt per meter power 2. Okay. Now, so we have the beam solar irradiance. We have diffuse solar radiation, and we have the reflective solar radiation. Which one is highest solar radiation? Yeah, from these three types. Yeah, remember the beam solar irradiation or solar irradiance or solar irradiance. Yeah, irradiance. Yeah, irradiation. Now, so the beam is highest. The lowest is reflective solar irradiance. Sometimes, yeah, some in the calculation, this reflective solar irradiance can be ignored. Why? Because it is very small. Yeah, compare these two part, and this solar diffuse solar radiation is medium lah value. Okay, now so we can calculate it by using this formula. Because beam, yeah, we just calculate the beam solar radiation. Now, so we use the IB equal A multiply E power minus KM. Now, so in here we have the first calculate the value of A. A is apparent extraterrestrial. Yeah. A in here is given by this one. By this one, sorry. A in here given by this one. Yeah, before it is here. 1160 plus 75 sinus 360 over 365 multiply n minus 275. Now, so meaning when we want to calculate the value of the beam solar radiation, the first we have to find the value of A. Now, so we calculate it using this formula. Yeah. A in here is number of day, 21. Yeah, now so how many number of day? Yeah, how many number of day in 1 year? Yeah, 21st. Yeah, meaning if we relate it to this table, This table, look at this table. Which one is it? This one. What date is it? Sorry. 20 May. Yeah, 21st May. 21st May. So 21st May. 21st May. First 20 first May. First May is 120. First May 121. Now, so 21st May should be added by 20. Now, so 121 plus 20 is equal to 141. Meaning the number of day or Julian day is 141. Yeah, we can look at here. Yeah, it is N, 141. Now, so we obtain the value of A is 1104 watt per meter power 2. After that, we have to calculate the value of optical depth K by using this formula. Yeah, K equal 0.174 plus 0.035 sinus 360 over 365 multiply n minus 100. N in here before have dimension is 141. Yeah, here 141. So by using this formula, we can obtain the optical depth is 0.197. Okay, obtain the value of K. And then we have to calculate the value of M. MS ratio. M is equal to 1 over sinus altitude angle, beta N. Yeah, beta N can be calculated by using this formula. Beta N is equal to 19 minus L plus delta. Yeah, L is latitude angle. The latitude angle, yeah, is mentioned in the question, 33.7. And the delta here is declination angle. Yeah, for the 21st May, yeah, following this table, yeah, has been mentioned. Which one is it? Yeah, which one is it? This one. 21st May. The declination angle is 20.1. So the value of delta n, yeah, delta n in here equal 90 minus 33.7 plus 20.1. Now, so is equal to 76.4. Now, so the air mass ratio can be calculated by using this formula. M is equal to 1 over sinus beta n equal 1 over sinus 76.4. So is equal to 1.0229. Yeah, this one is MS. After obtaining the value of A, K, and M, so last we can calculate the value of beam solar radiation is equal to A multiply exponential power minus K M. Yeah, A is 1104 watt per meter power 2. K is 0.197 and M is 1.029. Now, so we obtain the value of beam solar radiation is 902 watt per meter power 2. Okay, thank you very much.